We are thrilled to welcome colleagues from our PIC institution. So that stands for Peer Implementation Cluster. So these are institutions that we have been working with since we have been awarded the HHMI grant. And so we meet with colleagues from these institutions about once a year. Everyone involved in our projects and their projects come together and talk and share and learn. And the project directors also meet approximately monthly. So it is my honor to welcome Dr. Amanda Raimer from Radford University, Dr. Matthew Hemm from Towson University, and Dr. Deborah Good from Virginia Tech. So our first speaker to share work from Radford is Dr. Amanda Raimer. She is a teaching postdoctoral fellow at Radford, and she will be telling us about their project, Building STEM Identity and Community Through Peer Mentoring. So thank you and welcome, Dr. Raimer.
Great, thank you so much. So first of all, I want to thank the Cynthia, as well as the rest of the organizers, for having myself and the rest of the PIC team here to talk to you a little bit about what we've been working on in pieces of our program. So just give me 1 second while I share my screen. Let's see. All right, so here we go. So, like Dr. Deborah said, I'm here from Radford University, specifically from the Artist College of Science and Technology, to talk about a specific part of our grant, the peer mentoring program. All right, so who are we? So Radford University is a comprehensive public university located in the mountains of southwestern Virginia, on the original land of the Towson people. We have about 9,000 students at our college, between undergraduates and masters. However, in our College of Science and Technology, we only have master's students. So, and then looking at who our students are a little further, this current incoming class was 59% female, 36% Black, Indigenous, and students of color, and almost a third first-generation students. So the name of our grant here at Radford is Realizing Inclusive Science Excellence, or RealLife. And our grant is made up of 4 major components. The first of which is our project-based curricula, basically helping faculty design and implement project-based STEM learning in as many classes as possible. Related to that, we have a lot of other faculty development, either through specifically for our 3 departments of physics, biology, and chemistry, but we also work with the Center for Innovative Teaching and Learning on campus to infuse inclusive pedagogy into most, if not all, of our trainings. The third component is the postdoctoral teaching faculty like myself. We come in and gain more experience in teaching and other skills to become professionals, as well as providing release time for the permanent faculty to help redesign their classes with some of this new pedagogy. And then the final part, the part I'm going to be focusing on, is our peer role modeling program. And so this is students serving as senior mentors and helping other students build community and science identity in our college. So looking at the RealLife Student Program overall, our big 3 goals are to 1, help students build their identity within STEM, 2, help build their community within STEM, and then 3, help amplify their student voice so that they feel heard within this community. So who are our students? So we usually have about 8 to 15 students per semester between new and returning students. You can see all of our 15 students that we have this semester. They're majority biology, chemistry, and physics majors, which is where our grant is based, and all sophomores, juniors, or seniors. To become a RealLife student, they do go through a short application process as well as an interview with the faculty mentors to become part of the program. Again, we're not just looking for like the students with the best grades or in the most close, but also students who have persevered, right, showed persistence throughout their major and have gone through and overcame barriers that they can share with other students. This is a paid position and they work up to 7 hours a week, right, through our grant. And we have about three faculty mentors per semester working with them. And again, we as faculty mentors, myself and 2 others, work with them to help facilitate and sort of go through the logistics of the events, but it really is the RealLife students themselves that are creating, designing, implementing, carrying out on these different events and initiatives that they come up with to meet those 3 goals. We have group meetings every week where they're divided into planning, advertising, and assessment teams for each of the events that they carry out throughout the semester. Okay. And so another component of the RealLife Student Program is to provide them with some training to help them with these 3 goals. So one thing we do at the beginning of each semester is a workshop with Dr. Devin Swiner, aka Devin the chemist, to help students learn how to build inclusive spaces and create community within their groups. And then we also offer small training modules during the weekly meetings that focus on different skills that are important for our RealLife students, such as goal setting for the program, role-playing scenarios to help students overcome barriers, and also reflecting and assessing the events and initiatives that I put on to see if they actually met our goals and were effective. Some of the things we do with them are also help them think about their different identities and how that fits into their experiences in STEM, as well as discussing the identities of and demographics of the students at Radford and specifically the faculty and the students in our college. So back to our goals. So the first one is to help build STEM identity, particularly in incoming students, including freshmen and transfer students, and helping strengthen and maintain the identities that our upper level students have. And so we do that in a variety of ways. And so here are some of the events that the RealLife students have put on in the past. So one component is helping students explore their STEM identity. So events thinking about why they chose science, why they chose to be here at Radford in this specific department, right? And as well as this event that we just held this week, actually, again with Dr. Devin Swiner, focusing on imposter syndrome, helping students learn what it is, that it's common and they're not alone, and how to overcome imposter syndrome when they're experiencing it. Another component that we started implementing this past year is our Diversity in STEM series, where either virtually or in person, we have professionals from the different STEM disciplines come in and talk to our student population about their path through science, their careers, as well as how their various identities have impacted their experiences and their challenges and their successes as well. And then the final part of building STEM identity is the RealLife students themselves going into introductory classrooms and talking again about their experiences as STEM students at Radford, giving tips and answering questions that the new students have. And so these are quotes from students that were in these classes that the RealLife students went to. And you can see that they took away some skills such as the importance of time management. A lot of them talk about study skills as well, but also some less tangible things, right? So feeling connected and seeing people that you can relate to that look like you succeeding in your major, feeling more comfortable with your choice of major. And also persistence, right? Not feeling discouraged, wanting to keep trying, right? And realizing that these successful RealLife students that are in the front of the classroom struggle too, right? Encounter barriers. And just because, you're not doing well on a test or in a class, or if down here, like you can see, if they're still not sure what they want to do in their career, that doesn't mean they don't belong here. They belong here just as much as anybody else. So moving on to the second prong, we try to help build community with the students in our different departments, building connections and a network between students and other students, between faculty and the other members of our departments in our college. And so some of the ways we do that is one, the students held a STEM club fair that they put on, specifically focused on just clubs from the Artist College of Science and Technology to help the students hone in on groups and clubs and societies that might relate to their discipline of interest. We also just do plain old fun things, not super science related, but definitely some stress busters that get them out doing fun, creative things, and also meeting new people. So we do a lot of tie-dye. A student this last semester really wanted to do a terracotta paint potting activity, and so we collaborated with the greenhouse to get some plants as well. So we had our paint and plan. We've also done stress ball events, vision board nights, and again, these are all things that the students, our RealLife students, decided would be great events to do. And so they, again, thought up, created, designed, and implemented everything. And then one of our most well-known activities that we do is Fresh Fruit Friday. That's been going on for a few years now. And so basically every Friday in the science building, the RealLife students put out free fruit, coffee, breakfast items, hot cocoa, and things like that that students can stop by and grab on their way to class or stop and chat and meet some new people, as well as faculty that stop by. And so this semester, we've had a range of students participate in Fresh Fruit Friday. We've averaged almost 60 students a week. And it's become so well known across campus that our initiative has actually expanded to other colleges and units on the campus starting this semester. And then a less direct way, but really important way that our students help show support for our STEM students is through different flyers and things that they post up and handouts that they provide, whether it's from these posters with motivational pull tabs that students can take when they're needing a little motivation, little pick-me-up, as well as handouts that help with resources like stress relief and also other support resources across campus. And then the final goal we have, right, is to amplify student voice, specifically pertaining to creating inclusive environments and communities for our students. And the RealLife students do that through surveys. So an interested subgroup of our students have created and disseminated surveys throughout this past year, focusing what they were interested in. So this year they focused on classroom environment and comfort levels, as well as office hours environments. And so they're currently working on assembling the data, right? The results, you can see some of it over here, right? What kinds of things make students feel comfortable in classrooms, right? Do students feel that their professors are inclusive to all students? And they're working on, again, assembling that data into a deliverable that they can then pass out and disseminate to the faculty. All right, and so those are all the ways that the RealLife students work to help create a more inclusive and welcoming atmosphere for all of our STEM students here. But there are a lot of benefits for the RealLife students themselves. So when asked about it, these are some of the things that they said about the program. So they did talk about building skills such as creativity, leadership, as well as communication skills. But it also helped them feel a greater sense of belonging in the STEM community at Radford. That popped up in a number of different places in what they said, as well as just becoming more confident in their abilities as a science student. All right, and so lastly, right, we're thinking about how to sustain the RealLife students right after the grant's over. So we're working on transforming the student program into a club organization. That's what the students said they thought would work best. We're also trying to involve them with the new STEM living learning community that's starting in the fall. Like I said, Fresh Fruit Friday has expanded, so now every day, except for I think one, including the weekends, has some sort of similar event. And we're also, our upcoming quality enhancement plan that's being developed right now is based in part off of the RealLife program and what the RealLife students have been doing. So with that, I'd like to thank the whole RealLife leadership team, as well as past and present RealLife student faculty mentors, Erica Eccles and Nizer for their help with all the assessment, HHMI for the funding, and of course the past and present RealLife students, including all these you can see here that I've had the pleasure of working with the last few years. So with that, I'll take questions or wait till the end depending on what we're doing, but thank you.
Thank you so much, Dr. Raimer. Your RealLife students are doing amazing work, as are you and your team at Radford. Just to keep us on time, I think we will move right on to the next presentation, and then if we have time, we'll have questions at the end. So I would like to introduce Dr. Matthew Hemm, who is the Associate Professor in the Department of Biological Sciences and the Assistant Director of the TU Rep program at Towson University. So thank you, Dr. Hemm, so much for joining us, and we are looking forward to hearing your presentation.
Thank you very much, Cynthia. Let me make sure that I can share. Open preferences. Oh no. For some reason, it's not letting me share my desktop here. Oh, I apologize. This has never happened to me before. I apologize. Okay. So Cynthia, it looks like it's not going to let me share my screen until, nope, let me see. Do you see that? Does everyone see that?
Yeah.
Oh, okay, great. Well, let me start. Okay, so thank you again, Cynthia, and all the coordinators of this meeting, again, for giving me the opportunity to tell you how we've been trying to promote inclusive excellence at Towson University through the development of these course-based undergraduate research experiences, or CURES. And although I am the assistant director, this has been a project that's been done by many faculty, including Laura Goff, our director, Ramo Miranda, our head of professional development, and Trudy May Agboka, our student success coordinator, as well as many others. So our program, called TU Rep, stands for Towson University Research Enhancement Program, and it has three main goals. The first was to create these CURE classes to engage students, many students, in authentic research in the classroom. A second was to develop professional development for faculty to help them develop these CURES, but also to help us develop inclusive teaching that faculty could use when they teach the CURES, as well as their other classes. And finally, a third goal was to create and sustain student-focused support to ensure all students are retained in STEM while they're at Towson. Now, for my presentation today, I'm going to focus on the first goal, but if anyone has any questions about the other two, I'd be happy to answer those as well. Now, why CURES as a vehicle for promoting inclusive excellence? Well, it's been documented that CURE classes, where students can perform authentic research in a classroom setting, has been shown to increase retention and engagement of students in STEM disciplines. So that was something we were certainly shooting for. Also, our goal was to engage more students from more diverse backgrounds in authentic research. So students from underrepresented groups, transfer students, students that, like myself, when I was in college, who didn't realize that I was interested in research until well into my academic career. So these students traditionally have a difficult time getting an internship or an opportunity to work in a lab because we only have a few semesters left. And finally, these CURE classes are an opportunity for faculty to engage students in their research. So the goal is to help generate data that faculty can use to actually promote their projects. Now, what are cures? So if you're interested in getting a really good description of a cure lab, I suggest reading this great review by Auchincloss et al., published in 2017. This table is from that paper, and I'm not going to spend a lot of time going over it. What I'd only like to point out is a cure is designed to be a mix between traditional laboratory classes where students do discrete experiments to try to obtain some research goal. Can they clone this gene? Can they titrate the pH? And our traditional internship model where students are working in faculty labs to do their own undergraduate driven research. And so to do this, there are a couple interesting characteristics of a cure class. One is that the research that the students are doing should be novel. So the faculty doesn't know the results of the students' experiments, and neither do the students. So this creates an authentic research experience. And on the bottom here, you can see this great characteristic that they put in their table called the risk of generating messy data. And this is minimized in traditional labs, of course, because the faculty member or the teacher knows what the student should get, and they just need to achieve that goal. In a cure lab, since it's authentic research, this is an inherent process. And when they say inherent, that's a real nice way, I find, of saying it happens all the time. So in cure labs, we get messy data all the time. And so we try to develop that into the pedagogy so students can see how you work with messy data or unexpected data to keep your research going forward. Now, we have focused our program on developing a number of different cures in a diverse array of disciplines, but we've tried to keep all of the cures with a few core characteristics. One is that all the cures are in the research expertise of the faculty instructor. So this is something the instructor knows the most about and is best situated to teach students, and they'll get the most benefit of the students doing this research. The lab class, they are laboratory classes, so they typically take a large number of hours per week. So in general, there are about 6 hours per week of laboratory time. So for faculty, this can be a significant portion of their teaching load, the 6 contact hours per week, and the students will get three credits for participating in the lab. We have also tried very hard to integrate a large number of undergraduate learning assistants so that in the classes to help the faculty. And this has been a real success because it facilitates peer-to-peer mentoring. These undergraduate learning assistants are usually students that have already taken the class before, and they're in the class to help, be a resource for the current students, answering their questions and helping with the research. We would like all students participating in any of the cures at the end of the semester to get an opportunity to present in a professional setting. And so usually this is a poster session that's either run by the department or the university where students get this opportunity to present what they've done. And finally, a goal has been to try to expand beyond cell and molecular biology. At Towson and at other universities, we saw that most cures were in cell and molecular biology, so we wanted to try to help develop ones in other biology disciplines like ecology, as well as other STEM disciplines like mathematics, physics, geosciences, disciplines like that. Now, this is a list of the cures that faculty participating in the program have developed to date. So if you look, there are a diverse number of different classes offered here. I won't go through all of them, but I do want to mention 2 to give you an idea of the types of classes that faculty have developed. And this is the Organismal Form and Function Lab and the Molecular Biology Laboratory class. So the molecular biology laboratory class is our oldest cure. It was started in 2012, and it was originally funded by an NSF Career Award. And over the last 10 years, students, I think at this point, over 400 students have collectively worked through to identify new small proteins in bacteria, which is really nice because it's near and dear to my heart. It has been taught by multiple instructors. So I think to date, 9 faculty have taught the course. 5 are teaching it now on rotation. And in 2018, we were able to publish a paper that describes data that students got in the class in identifying these proteins, which was a nice result of the work. The second laboratory class I wanted to mention was the Organismal Form and Function Laboratory by Dr. Chris Ofiero. So this is outside of cell and molecular, but it still is in biology. In this laboratory class, students work on studying the physiological behavior and mechanics of insect movement. So what students do in the class is they develop hypotheses about the actual dynamics, the biophysics of insect movement. They then perform high-speed videography to quantify this insect movement and behavior. And you can see them in this picture. That's them analyzing a high-speed video on the computer. And then they analyze the data and determine if it supports or doesn't support their hypotheses. And Chris was able to publish a paper describing this class in 2019, which was really great. We have done some assessment, although we're in the early stages. We certainly have student evaluations, which have been almost universally positive, as well as anecdotal evidence. In the molecular biology laboratory cure for the last 8 semesters, we've given students just a basic Likert survey with a series of 10 statements and asking them to anonymously say whether they strongly agree, or not sure, disagree, or strongly disagree with each statement. And the results of this, we think, are pretty encouraging. So I'll just draw your attention to 3 of these statements. The first one, question 1, are they more interested in molecular biology than when they started the class? And over 90% of the students said agreed with this statement, which was great. In question 5, did the course offer valuable information that they could use in the future? And again, students, over 90% agreed with this statement. And then question 10, are you interested in graduate school or an MD, PhD? And over 70% of the students said they were interested. So certainly many more questions remain about the effectiveness and how we can make these classes even better, but it does look like we're engaging students in authentic research. Now we have a number of lessons learned, far more than I could tell you in 15 minutes or 20 minutes, but for anyone that's interested in developing a cure or participating in one, I did have 4 or 5 main lessons. The first is that our evidence suggests that cures are successful in engaging large number of students in a positive way in authentic research. So at this point, we generally offer between 4 and 5 cure labs a semester, and each one can enroll 15 to 20 students. So in a given semester, we can have between 60 and 100 students in the department engaged in authentic research, which was much more than was possible before we started the program. Teaching cures as a faculty member is more challenging than our traditional lecture and laboratory courses because you're asked to deal with new research while at the same time incorporating that into the pedagogy. So it is more challenging. It's kind of like tap dancing on quicksand some weeks, but it is much more engaging. You get to work with the students to, deal with authentic research, which is really gratifying for faculty. Related to this, we've found that faculty training and professional development and support is critical. So having a community of faculty that have also taught cures is really nice when you have a week where every student's group experiments didn't work and you're just like, what am I going to do next? Being able to talk it out with other faculty that have gone through that situation is invaluable. And then it's invaluable for the students because they can see what you do when this happens, which happens a lot when I do research. And finally, administration support is critical. These classes do take up more time. So a faculty member could spend 6 contact hours teaching 15 students in a Cure lab, or doing 2 traditional lecture courses, which might teach up to 60 students in a lecture class. So being able to have the administration there helping with scheduling and modifying teaching loads is very useful. And actually, my last lesson learned is one that we didn't learn here at Towson, but we learned through talking with and meeting with other HHMI funded groups that are also focusing on developing these cures. And what I'm showing is a pamphlet that was developed at Lawrence Technical University, where they are also working on cures, developing them in their program. They call them CREs, but it's the same thing. And what's fascinating about this, and they gave a great talk, is that they simplified the idea of a cure to have only 3 basic foci: discovery through scholarly practices, inclusive collaboration, and communication of relevance. And what was really nice about this is that by simplifying the requirements, it allowed them to actually start to develop cures outside of STEM. So they have cures that faculty have developed in English. They have cures that faculty have developed in philosophy. So really being able to just engage students in scholarly practices, not necessarily traditional research, was really exciting. So I wanted to mention it here. If you'd like contact information for the faculty that presented this, we'd be happy to send it to you. And with that, I'm finished. And again, I'm happy to take questions now or later.
Thank you so much, Dr. Hemm. Several of our faculty here are very interested in currently developing, or will be developing cures. So your lessons learned and the process is valuable to us, and I'm sure we will be reaching out for more information. As with before, we'll just wait until the end for our questions. And it is my pleasure to introduce Dr. Deborah Good, who is an Associate Professor of Human Nutrition, Foods, and Exercise at Virginia Tech. So welcome so much, Dr. Good, and we look forward to hearing your presentation.
Thank you, Cynthia. It's great to see everyone again. I know we've really, I think, formed a really nice bond in our PIC, and I'm looking forward to our yearly meeting in person this year. So I took a little bit of a different way of presenting some of this from my colleagues, although I really was appreciative of all the depth. I kind of did a little more skimming and a little more reflection on a faculty perspective. I am a co-PI of the Inclusive Excellence grant from HHMI at Virginia Tech. But I'm also faculty and also was part of our faculty groups. And I'll talk more about how we positioned our proposal and then grant in this. So first of all, I want to talk a little bit about Virginia Tech. We are Virginia Tech. The main campus is in Blacksburg, Virginia. It's a 26-acre campus. And I'm sort of setting these things up because we are a large institution, and so there are some things that might be easier for us to tackle and some things that are much more difficult to tackle. And one of those really is getting to know our students, especially in my department where there are over 1,000 undergraduates. So there are 280 undergraduate and graduate degree programs, 37,000 undergraduate, graduate, and professional students, over 2,000 instructional and research faculty. We are a research intensive institution. So faculty like me, although we do teach classes, we're expected to bring in research dollars. And right now, Virginia Tech is ranked top 5% nationally for research expenditures with a $556 million portfolio. However, we're also a land grant institution. The Morrill Act in the 1800s designated colleges in each of the states as land grant institutions, but we do acknowledge that we live and work on the Tuledo Monacan people's homeland. The Morrill Act took away some of those lands, and so we continue our relationship with their lands and waterways. We also recognize that enslaved Black people generated resources and revenue to establish Virginia Tech. But we're also prohibited from even attending Virginia Tech until 1953, which is fairly recently. So establishing those facts, I think, are important in setting the stage for our inclusive excellence work. So our inclusive excellence at Virginia Tech use departments as the unit of change. And these departments, and I hope you can see that, maybe I'll just pull up my laser pointer here, see sort of the cohort model. The departments are coming from 3 colleges at the university. That's the College of Agriculture and Life Sciences that I'm a part of, the College of Natural Resources and the Environment, and the College of Science. And each of those colleges contributed cohort faculty and then worked as a cohort during the entire first couple of years of the grant. Although, to tell you honestly, those who were in that first cohort and even the second cohort continue. I mean, it looks like we end here in 2019, but all of us have continued to be very active. And in fact, we had a meeting today with our IE faculty, and some of the people in cohort 1 and 2 do as much professional development or more than those in cohort 4, and then continuing on to hopefully a no-cost extension. So you can see some of the departments that have participated so far. And the cohorts are basically told to get professional development. There's lots of opportunities on campus, and also just new ones coming all of the time to basically learn not only from the data in their own department, and we have hired someone as well as working with NISER to really look in depth at our data. You know, we're a research one institution, so data for us is the key. And most of the faculty come in wanting the data. They want to know where we need change before they start to implement change. But also developing our faculty through these courses, through interactive groups, through meetings, to help faculty understand what it means to be inclusive, what diversity means, how to best approach some of the projects that we want to implement in all of our department programs. At the end of this year, each of the cohorts present to the rest of the faculty their ideas for departmental projects, and then in year 2 start implementing their departmental projects. And as I mentioned, even though we originally set it out with sort of these 4 distinct cohorts, all of them have continued now until 2022, actually, and have just been very active and fantastic to be around. So what I'm going to do is actually talk about our department. My title was from a faculty and departmental perspective, because I wanted to kind of give you both the big picture of what's going on at Virginia Tech, but honestly, there would be no way for me to cover all of that in that short amount of time. So I decided I would really focus in on what HNFE, the Human Nutrition, Foods, and Exercise Department, has done. And in particular, some of the things that have really meant a lot to me and that I feel have been good models that some of you may be able to use at your own institutions. So first of all, from our data, we learned a couple of things. First of all is, and Matt did a great job of introducing cures and the need for students to have experiential learning. We found in our program, again, we have 1,000 students in the major, at least, varies a little bit here and there, but 1,000 people in the major, that the science track students, 100% of them do some sort of field study or other experiential learning project. Now, I should tell you that our science track students don't all do undergraduate research. Some of them are going into physical therapy or medical school. And so their field study can actually be a shadowing. So I actually find that this data is a bit misleading from our senior students, that 100% of them do it, because it's not necessarily what I might think of as something where they're really learning in a cure or the other sorts of things that can give them hands-on during their course time or at Virginia Tech. Rather, it's probably more like shadowing. However, one of the things that we saw was only 1 in 65 transfer students, or about 1.5%, had any opportunity at all to participate in credit-based undergraduate research. And this really did lead us to develop some cures as well, because the information we got from our transfer students was that they just were transferring in and they really didn't feel like they had time. They had all these other things to do. And so putting it into the cure was great. The other thing that we have focused on during our years with Inclusive Excellence grant is the need, as I talked about, for faculty development. So faculty want to be able to do these things. And you know, obviously there's always some outliers in any department, but for the most part, people are really excited, but they just don't even know where to start. And they don't know how to implement things, but they also don't have a lot of time in their busy schedules to take a lot of classes on it. So we had to find ways to develop faculty training that didn't take a lot of their time or did it during when they were doing something else. And I'll talk about ways we implemented that. And then finally, an area I'm not going to talk too much about, but has been pretty successful, is in really thinking about students who may be potentially left behind in some of our inclusive excellence work, maybe because they don't fall into those distinct categories, but we're thinking more here about people whose life circumstances may have prevented them from really being full-time in an academic career, participating in maybe some of the outside clubs or any kind of research. And so some of our faculty, and now it's really gone around the university, are getting more training in what we have called our Second Chance program. It's in really focusing on training people in mental health, substance use disorders, maybe someone who's a caregiver or partner of a substance use disorder. And we feel like some individuals like that may be more interested in programs such as human nutrition, foods, and exercise, because of the problems that they've had and in their life. And so we want to make sure that we're well trained to be able to help them and to know what kind of best practices to use. And like I said, this is an area that we're still working on. People have been very engaged on, but it's actually not one that I'm going to talk about as much today, just because I haven't personally been as involved in that area. So getting from the faculty perspective, I want to talk about a couple of things that we have done to try to integrate faculty level training into just the everyday things that faculty already would do. And so first of all, one of the first things that I started doing, and now this is 4 or 5 years ago, is I was able to talk to my department head, and we have diversity, equity, and inclusion agenda items on every faculty meeting agenda. And this is just now part of the norm. It's something that is talked about at every faculty meeting. It could be just upcoming events. It could be where I might give a quick how-to. Maybe I've done things like, I've done a little syllabus thing. This is a different flyer, but I've done a syllabus talk. I've done how to caption your Canvas videos. I've done some things on a data presentation of what the students look like in our department. In terms of our, academic achievements and how many have done research and those sorts of things. But it has just become the norm, that every faculty meeting, there's something about diversity, equity, and inclusion going on. The other thing is I was the diversity, equity, inclusion representative. I was really a number of one doing it. And now we have formed a committee that actually takes over this. And with the committee, we get much more input and insight into the sorts of things we should be talking about. Pre-COVID, we used to have monthly seminars that were called Lunch and Learn. These actually took place throughout our College of Agriculture and Life Sciences. Everyone was invited. It was during lunch. Food was provided. I think that's a key. Like if you're going to have a lunch seminar, you got to have food. And you can see this is example, these two over here are examples of things we talked about. Manners group and the students of color. We talked about inclusive syllabi, and there were many other topics that were there pre-COVID. And I've got to say that we have just not gotten it back up going again yet this semester. I mean, this would have been the first semester we could have done in person, and I just didn't have the time, I guess, to do it. So it has not gotten going, but I think we can really implement it again. And then finally, seminar series that we had during COVID with some additional money from the College Diversity Fund was to bring in individuals to complete a badging system that was called Inclusive Pedagogy through the lens of health, nutrition, and exercise. And here we really looked for other faculty at other institutions who were doing inclusive pedagogy work, but were already in like nutrition or exercise science departments, which some of the things that we like to talk about that can be probably done in a more inclusive way are some of our health issues, disease issues, obesity, even ways of talking about patients. So it's a patient with obesity, not an obese patient, for example. So even changing subtle things like that, using diverse examples in some of our case studies and things like that. So that's really the inclusive pedagogy that happened within the Department of Human Nutrition and Exercise at the faculty level. At the university level, there are courses all the time that are online and in person now. There's a whole category through our TELOS, which is learning. Oh gosh, I don't know. We have so many acronyms at Virginia Tech, but it's called our TELOS program, and we have lots of opportunities for training. So to talk really quickly about the inclusive pedagogy at the student level, my big thing was putting more experiential learning into the curriculum, more team building, more things that students felt like part of a group, no matter where they were coming in from. And so we have a transfer student orientation and HNFE courses. The instructor who teaches that has included lab tours in there so that students understand that is part of something they can really get involved in. And we've had more students that are transfer students now participating in HNFE laboratories. You can see over here, there's also a lot of team building exercises in that course. For one of my courses called Metabolic Nutrition, I developed a course-based undergraduate research experience, really thinking about and hearing Matt talk about these all the times, based on the student had to be in metabolic nutrition, but then would take a gene, and we actually had funds through the Office of Undergraduate Research to buy 23andMe kits to test everyone in the metabolic nutrition course. I've actually published on this, so I can send the paper if you guys are interested. But we linked the cure to a required course in HNFE, and we have some really interesting results about the students and who have basically some changed their career entirely from thinking they were going to medical school to now going to get their PhD, or maybe not even knowing at all what they wanted. And there's one student who's out in California and just doing amazingly at a biotech company. We also fund money for undergraduates to travel to the Southeast Conference on Sports Medicine meeting. every year. This is an example here of that. This is just an amazing experience for the students. This year, our students who won the trivia contest, like of everyone in the Southeast, they won the trivia contest and they're going to nationals paid by ACSM. And then just recently, I've developed another cure called Eating for Your Genes. It's teaching genetics with the genetics of nutritional disorders and then recipe development from those. So I've been very inspired to try to think about ways that I can teach my courses with a cure embedded in those. And then departmental wide, I actually mentioned that previously I was the single DEI representative, but we now have a committee. And I actually would mention that they send out amazing newsletters to the faculty, reminding them of the important dates, giving them a historical perspective, highlighting alumni, et cetera, every month. They do a fantastic job that a single DEI representative to a department cannot do. I also implemented the Human Nutrition, Foods, and Exercise Book Club. We're now in our second semester and have had wonderful turnout of undergraduate, graduate students, faculty, staff, and alumni participating in books that have a DEI theme. We just finished reading The Bluest Eye by Toni Morrison. Actually, yesterday was our book club. And this is a great way that non-academically we are integrating with our students and getting to know our students. It's so important when you have a huge department like we do to have ways that are not part of a course to get to know our students. And then something else I've been really kind of into has been one of my things is I'm past president of the Virginia Tech chapter of Sigma Xi and past associate director of the Mid-Atlantic Consortium at Sigma Xi. And so I love Sigma Xi. I was recognized as an undergraduate student researcher by Sigma Xi, and I've continued. And I think it's so important to recognize everyone who is doing research by nomination to this honor society. And so I have money to induct researchers who present at the spring Office of Undergraduate Research Symposium. I've also worked with local high schools when students present at the local high schools and really starting them early as being inducted into this honor society. And then for this year, I actually came across a pot of money, which I've used to develop a 4-week intensive research experience. And we're going to be assessing this because we think that it may be a sweet spot in the number of weeks that some individuals who may, have situations in their lives that they can't have a 10-week summer undergraduate research program, but they want to have that intensive immersion into research. And so we're going to be really looking at these individuals that participate in our 4-week intensive research experience and see if this is a good way of getting people kind of jump started into undergraduate research over the summer. I'd just like to mention our HHMI Virginia Tech team, and I'm proud to be sort of representing our team, Dr. Jill Seibel, who's the PI for the HHMI grant, Dr. Sarah Carpenti, who's from the College of Natural Resources and the Environment, myself from College of Agriculture and Life Sciences, and Dr. Michael Bowers, who unfortunately has passed away, and he was our representative from the College of Science. We also have all of the IE faculty from College of Science, CALS, and CNRE departments across campus who have really done fantastic projects that there's no way I'd have time to talk about today. So what can you do in your department?
Thank you so much, Dr. Good. That was wonderful. You're doing such great work. And thank you to all of our colleagues, our PIC institution colleagues. We thank you so much for joining us today. I'm sorry we don't have time for questions. We have our keynote speaker here now. But again, thank you, everyone.